Look out into the night sky. Every glimmer you see is not just a star, it's part of a galaxy, one among trillions. Yet not all galaxies look alike. Some swirl gracefully like cosmic pinwheels. Others loom as vast, glowing elliptical orbs. And a few are chaotic, seemingly torn apart by invisible hands. Why this diversity? Why does the universe sculpt such different galactic forms from the same cosmic ingredients? In this episode, we unravel that mystery, tracing how gravity, dark matter, rotation, and time conspire to shape galaxies into spirals, ellipticals, or irregulars. This isn't just about appearances, it's about destiny, because a galaxy's shape tells the story of its birth, its struggles, and its future. Every galaxy begins as a cloud of primordial gas, a mix of hydrogen, helium, and dark matter swirling in the aftermath of the Big Bang. Over hundreds of millions of years, these clouds begin to collapse under gravity. But whether the result becomes a delicate spiral or a featureless sphere depends on three forces: mass, spin, and time. If a forming galaxy spins rapidly, centrifugal force prevents total collapse. The material flattens into a rotating disk, like a cosmic record. Over time, density waves sweep through this disk, creating the elegant arms we call spirals. If the initial rotation is slower, or if the forming galaxy is massive enough, gravity wins the battle. Gas collapses inward from all directions, forming a dense, rounded ball of stars, an elliptical galaxy. Time, too, plays a role. Spirals are young and dynamic, ellipticals are old and settled. What we see in the night sky is not a moment, but a timeline. Galaxies frozen at different stages of evolution. Astronomers measure these relationships through something called the Tully-Fisher relation, a law that connects a spiral galaxy's rotation speed to its luminosity. The faster it spins, the brighter and more massive it tends to be. This connection reveals how angular momentum preserves order even as chaos reigns in the wider universe. Ingredients? In this episode, we unravel that mystery, tracing how gravity, dark matter, rotation, and time conspire to shape galaxies into spirals, ellipticals, or irregulars. This isn't just about appearances, it's about destiny. Because a galaxy's shape tells the story of its birth, its struggles, and its future. Spiral galaxies are the icons of the cosmos. The Milky Way, Andromeda, and countless others stretch their arms across millions of light years. They are dazzling, colorful, and alive with star birth. But what keeps those elegant arms intact? Shouldn't they wind up and blur after billions of years? Here enters the density wave theory, one of astronomy's most beautiful ideas. The arms aren't fixed structures of stars. They're waves of higher density moving through the galactic disk, like ripples on a pond. As the wave passes, gas compresses, triggering new star formation. Young blue stars light the arms before aging and fading, leaving the pattern intact. Many spirals, including our Milky Way, also feature a central bar, a straight structure of stars connecting the spiral arms. This bar acts as a gravitational engine, funneling gas inward to feed the central bulge and even the supermassive black hole at the core. Spiral galaxies are cosmic nurseries. Their disks are rich in cold gas and dust, ideal ingredients for new stars. Their thinness and rotation make them visually spectacular and scientifically crucial for understanding how the universe recycles matter. If spirals are the dancers, ellipticals are the ancient titans, massive spherical galaxies glowing with the red light of old stars. They contain little gas, almost no dust, and hardly any ongoing star formation. How do these smooth behemoths form? Through violence. When two or more spiral galaxies collide, their delicate disks are destroyed. The gas clouds crash, triggering brief, furious starbursts before the gas is exhausted or expelled. What remains is a gravitationally bound swarm of stars moving in random orbits, a featureless elliptical galaxy. In the 1920s, Edwin Hubble introduced the famous Hubble sequence, a diagram classifying galaxies from ellipticals to spirals to irregulars. Early astronomers believed it was an evolutionary track, spirals aging into ellipticals. But modern research tells a more intricate story. It's not linear. Ellipticals are often the aftermath of mergers, not the destiny of all spirals. Massive ellipticals reside in the densest regions of the universe, galaxy clusters, where collisions are common. Smaller ellipticals may form through gentler mergers or the slow loss of gas over cosmic time. Still, the story doesn't always end in dormancy. Some ellipticals can rejuvenate, pulling in fresh gas from smaller companions, reigniting bursts of new stars. Even these old giants sometimes get a second act. Beyond order and symmetry lie the misfits of the cosmos, irregular galaxies. They defy neat categories, crooked, fragmented, distorted. To some, they look like cosmic accidents. To astronomers, they are laboratories of evolution. Irregulars often form when smaller galaxies are disrupted by nearby giants. Their shapes are torn apart by tidal forces or twisted during close encounters. Sometimes they're simply galaxies that never grew large enough to organize themselves into spirals or spheres. The large and small Magellanic Clouds, visible from the southern hemisphere, are prime examples. These dwarf irregulars orbit the Milky Way like restless satellites, their gas stripped by our galaxy's gravity. Despite their chaotic form, they teem with star-forming regions, proof that disorder can be fertile ground for creation. Astronomers studying the early universe with the James Webb Space Telescope have found countless irregulars at great distances. These are young galaxies, still assembling, colliding, and learning to rotate. Their strange shapes aren't mistakes. They're the first drafts of the grand cosmic design. In the universe, nothing stays still. Galaxies drift through space for billions of years, and gravity inevitably pulls them together. When they meet, their destinies change. Spiral galaxies that collide head-on can lose their structure entirely, transforming into massive ellipticals. Smaller interactions, called minor mergers, can warp disks, twist spiral arms, or create long tails of stars. These are called tidal streams, and they trace invisible gravitational currents between galaxies. Computer simulations, such as the illustrious TNG and Eagle projects, let astronomers watch billions of years of evolution unfold in minutes. They reveal a universe where collisions are not rare catastrophes. They are routine, essential events that build complexity. Collisions also ignite supermassive black holes, triggering bursts of radiation called quasars. These energetic outflows can sweep away gas, shutting down star formation and locking galaxies into their final forms. In this way, collisions don't just shape galaxies. They decide whether those galaxies live vibrant lives or fade into quiet extinction. The visible universe, the stars, the gas, the dust, makes up less than 5% of all that exists. The rest is dark matter and dark energy, unseen but essential. Every galaxy is enveloped in a dark matter halo, an invisible sphere of gravity that anchors it. Without this hidden scaffold, galaxies would tear themselves apart under their own rotation. The shape and size of this halo influence whether a galaxy forms a flat disk or a round ball. Environment plays a crucial role too. Galaxies in dense clusters experience gravitational harassment from neighbors, stripping away gas and triggering transformations from spirals into ellipticals. Those in isolation, free from such encounters, often retain their graceful spiral shapes for billions of years. Recent James Webb Telescope images have revealed that these processes started earlier than we thought. Some galaxies already had well-defined spirals only a few 100 million years after the Big Bang. This discovery forces astronomers to reconsider how quickly order emerged from cosmic chaos. At the dawn of time, the universe was filled with turbulent clouds of gas and dark matter, clumping under gravity. The first galaxies were messy, irregular, and unstable. Over eons, they cooled and flattened into orderly spirals, structures that spoke of balance and rhythm. But time never stops. Spirals merge to form ellipticals. Ellipticals cannibalize dwarfs, and new irregulars emerge from the wreckage. The cycle continues endlessly. Each galaxy is both a product and a process, born from collisions, sculpted by gravity, and constantly remade. The Milky Way itself has absorbed dozens of smaller galaxies. Its spiral form hides a violent history of mergers and rebirths. From chaos to order, from order back to chaos. That is the rhythm of the cosmos. Galaxies are not static pictures, but living timelines that evolve across billions of years. In about 4 billion years, the Milky Way will collide with Andromeda. Two majestic spirals will intertwine, their arms shredding into streams of stars. The central black holes will spiral inward, merging in a final burst of gravitational waves. The end result? A smooth, massive elliptical galaxy. For now, though, our galaxy remains a thriving spiral, its arms glittering with star nurseries, its bar rotating like a heartbeat. But this future collision reminds us that even the most stable shapes are temporary sculptures in a universe of motion. One day, far beyond human memory, our descendants, if any remain, will gaze upon a new sky. No longer the familiar spiral arms, but a brilliant glowing oval, the merged Andromeda galaxy. And they will stand upon a world shaped by forces older than life itself. Why do some galaxies look like spirals, others like ellipses, and some like shattered glass? Because the universe writes its history in shape. A spiral tells of youth, rotation, and abundance. An elliptical whispers of age, collision, and exhaustion. An irregular speaks of struggle, transformation, and rebirth. Each form is a stage in the grand cosmic life cycle, a reminder that beauty and order emerge not despite chaos, but because of it. As we look deeper into space, we aren't just seeing galaxies. We're seeing stories, billions of years long, written in light and gravity. The cosmos doesn't design by chance. It sculpts, reshapes, and evolves again and again until every galaxy becomes what it was destined to be. Because in the universe, as in life, form always follows fate.